Today we're going to talk about inverses, and we're going to learn how to do them with a 2x2 matrix by hand. So if we're given matrix A, the inverse of matrix A is equal to 1 over A times D minus B times C times, we're going to flip the positions of a D and A, so D goes here and A will go there. We're going to negate B and C. And notice the denominator right here is how you would find the determinant of a 2x2 matrix. Now we're going to see an example. So if we're given matrix A, and now we want to find the inverse of matrix A, we're going to do 1 over, and we're going to take A times D, so 4 times 6, minus B times C, so 7 times 2, and when we simplify that down, we get 24 minus 14, which is 10. And it's going to be times the matrix. We're going to switch the spots of A and D, so 6 goes here and 4 goes here, and we're going to negate B and C, so negative 7 and negative 2. So I'm going to rewrite this down here where we have 1/10 times our matrix, and this is scalar multiplication, so we're going to multiply the 1/10 by each piece of the matrix. And when we do that, we get 6/10, negative 7/10, negative 2/10, and 4/10. And our final step here is going to be that we're going to want to simplify our fractions. So 6/10 reduces to be 3/5, and then we have negative 7/10, which does not reduce. And then we have negative 2/10, which reduces to be negative 1/5, and 4/10 reduces to be 2/5. And so this is your final answer and the inverse of matrix A. So it's important to note that if you take matrix A times the inverse of matrix A, it's the same as saying the inverse of matrix A times matrix A, which will equal I, or which is known as our identity matrix, which for a 2x2 matrix is 1, 0, 0, 1. I'm just going to make a note that this is our identity matrix. And our final note is going to be that if your determinant is equal to 0, then the inverse does not exist. And another way to write doesn't exist for shorthand is DNE.